This problem number 1, if you consider, in the entire mechanism, one external force is acting. A force of 1000 Newton is acting on the piston or slider. A force of 1000 Newton is acting on slider, and in the entire mechanism, that is the only force acting. But if you consider this problem, in this mechanism, there are two forces. A force of magnitude 2000 Newton is acting on slider. Apart from that, there is one more force of magnitude 800 Newton which is acting on link number 3. So first, whenever question is given, you have to redraw it on your answer book by using some suitable scale. So they have followed scale 1:10. It's up to you. You can follow your own scale. So they have taken scale 1:10. So 300 mm will be 30 centimeter. This one will be 60 centimeter, and this one will be 20 centimeter. If it is 60 centimeter, then I don't think it will fill in your answer sheet. So better to take scale 20:1, if not 30:1. You can also take 100 mm is equal to 100 mm is equal to 1 centimeter. Like this you can take, so that this will be 2 centimeter. 200 mm is 2 centimeter. This will be 6 centimeter, and this will be 3 centimeter. AB will be 3 centimeter. And I hope you know how to plot this diagram on the answer sheet. First, let me start with point A. Length of AB is 300 mm, and it makes an angle of 45 degree with respect to horizontal. So first, draw one horizontal line. And from horizontal, take angle 45 degree. This angle should be 45 degree. This is point A. And mark B at a distance of 300 mm from point A. So cut one arc of radius 300 mm. So this is B. And the last step, length of BC is 600 mm. So from B, cut one more point or one more arc of radius 600. This radius must be 600. And here, locate one slider, draw one slider. Length of BC is 600 as given in the diagram. This is point C. A force of 2000 Newton is acting on slider C. This is 2000 Newton. And apart from this, there is one more force, 800 Newton, acting at point D, which is located at a distance of 200 mm from B. Here it is given BD is 200. So from B, at a distance of 200, from B, at a distance of 200, this one has to be 200, locate point D, and at point D, there is a force of magnitude 800 Newton, which is inclined at an angle of 60 degree with respect to link BC. So from this line, this 800 Newton is making an angle of 60 degree. So like this, complete the diagram first. This free body diagram carries around 3 to 4 marks. So after this, what you have to do is, so how many forces are there in the system? There are two forces in the system. Since there are two forces, we'll divide entire procedure into two parts. So we'll divide solution into two parts, or we'll divide solution into number of parts depending on number of forces present in the system. Here there are two forces, so we'll divide solution into two parts. And first part of the solution, this is by considering only 2000 Newton. We'll assume that there is only one force in the system. A force of 2000 Newton is acting on slider C, and there is no 800 Newton force. So like that, we'll solve first part of the solution. And in second part, what I will do is, we'll consider only 800 Newton and will neglect 2000 Newton. So in second part, we'll consider only 800 Newton, we'll neglect 2000, we'll complete the solution and we'll calculate what are the forces. And final answer, in order to get final answer, you have to add, you have to consider both the forces. While calculating final answer, you have to consider both the forces. So you have to combine, or you have to add result obtained in first part and result obtained in second part. So by combining result obtained in first part and second part, you will get the final solution. So now first part, in first part, we'll neglect this 800 Newton, we'll consider only 2000 Newton. You can draw one more diagram. You can draw one rough diagram now. For this diagram, scale is not necessary. For this diagram, I'm telling, I'm considering only one force of magnitude 2000 Newton. This is 45 degree. A, B, C. So this is part 1. First part 1. I'm neglecting this 800 Newton, considering only 2000 Newton. And now if you consider this diagram, this is very similar to problem number 1. That is very similar to problem number 1, in which there is only one force, a force of certain magnitude on slider number 4. Even here, there is only one force which is acting on slider present at C. So you have to solve this first part similar to problem number 1. So we'll tell you how to solve this one. So after drawing this diagram, next what you have to do? Next, you have to consider individual links separately. So before that, how many links are present? All fixed components will be link number 1. AB is link number 2. BC is link number 3. And the slider is link number 4. It is given in the diagram also. It's given in the question also. Fixed portion link 1. This crank or link AB is link number 2. Connecting rod link number 3. And slider is link number 4. Now consider these links individually. This is link number 2. I'm considering these links individually. Link number 2, link number 3, and link number 4, which is a slider. And I hope you remember, while drawing these diagrams, while drawing these individual links, only direction is important, length is not important. So while drawing these individual diagram, angle is important. Here 2 must be parallel to link number 2, 3 must be parallel to link number 3. But length of link number 2 and 3 is not important. You can note down that only direction or angle is important. Magnitude is not important here. Now note down different forces acting on individual links, and from which link you have to start, whether to start with link number 2, 3 or 4. Even that I told you in the previous class. You have to start with the link on which there is one known force. So a force of 2000 Newton is acting on link number 4. So you have to start with link number 4 and mark which are the forces acting on link number 4. There is a force of 2000 Newton on link number 4. Newton on link number 4. A force of or two more forces. So how can you identify number of forces acting on individual links? To identify that, you first note down this link number 4 is connected to link number 3. Link number 4 is connected to link number 1. 4 is connected to 3. 4 is connected to 1. Therefore, link number 1 is applying force on 4. Link number 3 is applying force on 4. So we'll write this one as F. 1 is applying force on 4. Link 3 is applying force on 4. This is very similar to previous problem. So these are the three forces acting on link number 4. After this, we'll move to link number 3. Which are the forces acting on link number 3? To identify that, link 3 is connected to link number 2. Link 3 is connected to link number 4. Therefore, two forces are F4 will be applying force on 3, F43. 2 will be applying force on 3, that is F23. F43 and F23, these are the two forces acting on link number 3. And what will be the direction? To identify the direction of F43 and F23, how to refer previous diagram and check, do you have either F34 or F32? I don't have F32 in previous diagram, but I'm having F34. Direction of F34 and F43 will be opposite to each other. These two will be equal in magnitude but opposite in direction. Therefore, direction of F43 will be opposite to F34. So we'll draw a line. F43 here will indicate F43 here, and F43 and F34 must be parallel to each other because these are equal in magnitude but opposite in direction. So this will be the direction of F43. And when only two forces are acting on a system, second force will be, for the equilibrium, second force will be equal in magnitude but opposite in direction. So this will be the orientation of F23. F23 is opposite in direction compared to F43, but the magnitude of F23 and F43 will be equal. That completes link number 3. And moving on to last link, link 2. How many forces? Link 2 is connected to link 3. Link 2 is connected to link 1. Therefore, two forces are F2 will be applying, 3 will be applying force on 2. 1 will be applying force on 2, F32 and F12. Out of these two, whose dimension or whose direction is known? For that, you have to refer previous diagram. You refer previous diagram. In the previous diagram, check, do you have F23 or F21? I don't have F21 here, but I am having F23. F23 and F32 will be equal in magnitude but opposite in direction. So this is the direction of F23. Therefore, F32 will be equal in magnitude but opposite in direction. So from this diagram, it is clear that these two are parallel to each other. And this one is F32. Now last one, F12. Since there are two forces, F12 will be equal. F12 will be equal in magnitude but opposite in direction. So apart from these two forces, there is one torque also here, torque 2 or T2. You have to indicate this torque in question also. It's missing in the question. T2. So that completes individual link diagram of all the three links. Link number 4, link number 3, and this is link number 2. What is the next step? Next step, you have to plot,
In the last problem, it was said that like when the torque is acting,
okay.
the direction of the force will not be same. Sorry, opposite.
Actually, in the previous problem, I told you direction is unknown, so we'll simply mark one line here. But in the final step, if you calculate magnitude of F12 and F32, you will get magnitude of these two. You will get same magnitude, equal magnitude. You
Same
will get.
magnitude.
Yeah.
Yes. Okay.
So it's up to you. You can simply draw one line here. If not, you can indicate one more line which is equal in magnitude or opposite to F32. But in final answer will be same. F32 and F12 will be same. So after plotting this individual diagram, next step you have to plot force polygon. You have to plot force polygon for link number 4, link number 3, and link number 2. But which one to start with? I told, yeah.
Can you explain link number 3 again? I am a little bit confused. I cannot understand properly that one.
Link number 3. We'll draw it here. First, draw link number 3 parallel to this one. This is link number 3. Identify which are the connecting rings. Link number 3 is connected to link number 2. Link number 3 is connected to link number 4. Therefore, two forces acting on link number 3 are link 2 is applying force on 3. Link 2, 3. Sorry, force 2, 3. 3 is connected to 4. So 4 will be applying force on 3. So you have 4, 3. These are the two forces acting on link number 3. Out of these two forces, in order to identify direction of any force, you have to refer previous diagram. So previous diagram is this one. Previous diagram is this one. In this diagram, check whether you have F32 or F34. I don't have F32 here. There is no F32, but I'm having F34. I'm having F34. So F34 and F43 will be equal in magnitude but opposite in direction. Therefore, I know the direction of F34. This is the direction of F34. So the direction of F43 will be opposite to that. This will be the direction of F43. These two must be parallel to each other. Equal in magnitude but opposite in direction. So you have to draw a line parallel to F34. F34 and F43 will be parallel to each other. So I got the direction of F43. So this one is over. Now the second force F23.
Sir,
So
what
yeah.
about Q800?
So that I told you in the,
800
yeah, that I told you in the first starting itself.
Yes, sir, we took 2000 as a maximum. Can we what about 800?
Yeah, that's what I'm telling. Here we are dividing entire solution into two parts. This is first part, part 1. In part 1, what I'm doing is we'll neglect this 800 Newton. We'll consider only 2000 Newton. So the diagram will be like this. I'm not considering 800 Newton here. I'm not considering. And in part 2, what I'm doing is we'll neglect this 2000 Newton. We'll consider only 800 Newton and we'll complete the solution. So I'm in part 1 now. In part 1, I'm considering only how much is this? Yeah, 2000 Newton. I'm considering only 2000 Newton in the first half. I'm neglecting 800 Newton. So out of this, or moving back to link number 3, there are only two forces, F23 and F43. Since there are only two forces, for the balancing of this link, second force must be equal in magnitude but opposite in direction. For the balancing of the link number 3, second force, that is F23, must be equal in magnitude but opposite in direction. So this will be the direction of F23. So like this, you have to complete free body diagram of individual links, then move to force polygon. And while constructing force polygon, next question is whether to start with link number 4, link number 3, or link number 2. Even that I told you in the previous problem. I'm constructing one polygon here. Polygon means minimum 3 edges has to be there. 3 edges means 3 forces. So you have to consider a link in which there are 3 forces. Link number 2, if you consider I'm having 2 forces and a torque, so I'm not considering that one. Link number 3, if you consider you're having only 2 forces, so even that ruled out. But link number 4, if you consider there are 3 forces, 2000, F34 and F14. Since I'm having 3 forces, I can construct one polygon using these 3 forces. So first I will construct one force polygon for link number 4. We'll construct a force polygon for link number 4, and this procedure is similar to previous problem. First, or you can note down which are the forces acting on link number 4. There are 3 forces, 2000, F34, F14. Forces are 2000, F34, F14. These are the 3 forces acting on link number 4. Here we'll write magnitude, M for magnitude and D for direction. Magnitude of 2000 Newton is known. Magnitude is 2000. What about direction of 2000 Newton? Even direction is known. This is the direction of 2000. Direction is known. It is exactly horizontal. Magnitude is 2000. So both magnitude and direction is known. What about F34? Whether its magnitude is known, magnitude is unknown. But what is the direction of F34? So if you refer previous diagram, F34, this is the direction of F34. This is the direction of F34. F34 is acting in this direction. Therefore, direction is known, magnitude is unknown. Last force F14, even its magnitude is unknown, but its direction F14 is acting exactly vertical, in exactly vertical direction. This is the direction of F14. So direction of F14 is known. Direction of F14 is known. Now we'll plot the force polygon, and for this force polygon, scale is must. Without taking proper scale, you cannot construct this diagram. You can take 2000 Newton is equal to around 2 centimeter or 4 centimeter. 1000 Newton is equal to 1 centimeter. If not, 1000 Newton is equal to 2 centimeter you can take. Better to take 2 centimeter. So this is 2000 Newton. 2000 Newton is equal to around, depending on your scale. So let me consider this one as 4 centimeter. So one line is complete. Second line is F34. Its magnitude is unknown. Magnitude means length of the line is unknown, but its direction is known. So what I will do is, we'll draw a line parallel to F34, the previous diagram. This is the direction of F34. So we'll draw a line parallel to F34. So from here, we'll simply draw a line parallel to F34. This is parallel to F34, but its length is unknown. And the last force F14, again its length is unknown, but direction is known. Direction is exactly vertical. If you refer previous diagram, direction of F14, it is exactly vertical. F14 is present here. So it's exactly vertical. So from this point, we'll draw one vertical line. Now this intersection point, you can mark it as point C, this one as starting point as point A, and the second point as point B you can mark. Now this line represents F34 and the vertical line represents F14. So if you measure AC, you will get magnitude of F14. If you measure magnitude BC, you will get magnitude of F34. Not the total length, you have to measure up to C point. So BC will be magnitude of F34, AC will be magnitude of BC, multiply by scale factor, you will get F34 BC into, sorry, BC into scale factor, you will get F34, and AC represents F14. Now I got what is F34, also F14. So its work is complete. We'll move to next link, link number 2. Sorry, not link number 2, link number 3. Link number 3. This is for link number 4. This is for link number 4. Then we'll move to link number 3. And the answer is F34 value, I think. 1 second. It's not there in the solution actually. F34 value. Sir, I'm not having value of F34 and F14. Its value I don't have. Better you can solve yourself and you can check the value. I can give you textbook value. Textbook value is, they are using some different method. Textbook value F34, it is 2250 Newton. Textbook answer is F34 is 2250 Newton. This one is 2250 Newton. And this one is 1000 Newton. F14 is 1000 Newton. 1000 Newton. Now we'll move to link number 3. Which are the forces acting on link number 3? You can refer previous diagram. Link number 3, if you consider two forces F23 and F43. Two forces are F23 and F43. Since there are only two forces, I cannot construct one polygon for this one. For constructing force polygon, I need minimum 3 forces. Since there are only 2 forces, I cannot construct one force polygon here. Magnitude and direction. So from the previous diagram, its direction is already known. This was the direction of F43 and this was the direction of F23. F23. This direction I've already noted down here. Direction of F23 and F43. It's been marked here. So direction of F23 and F43 is known. What about magnitude? F34 is equal to F43. I told you already F34 is equal to F43. And here F43 is equal to F23. Since there are only two forces, F43 is equal to F23. So all these forces will be same and its magnitude of F34 is 2250. 2250 Newton. So this is the magnitude of all F34, F43 and F23. And we can complete this table. 2250. And even this one is 2250. And if you have any doubts like why these two forces must be equal, that is because if these two forces are not equal, then the system will not be under equilibrium. So for the static equilibrium of the link number 3, these two forces must be equal in magnitude and opposite in direction. Now moving on to last link, link number 2. Link number 2. Draw a line parallel to link number 2. Link number 2. Which are the forces acting on link number 2? F32, F12, and a torque. Magnitude and direction. Magnitude and direction. Do you know the magnitude of F32? F32 and F23 will be equal. F23 is equal to F32 equal to F12. F12. Therefore, this magnitude will be F23 is equal to 2250. 2250. So this magnitude is 2250 Newton. Even this is also 2250 Newton. Torque is unknown. You have to find out. Torque value you have to find out. What about direction of F32 and F12? F32 will be equal and opposite to F23, so its direction will be like this. This will be the direction of F32. Equal and opposite will be F12. Now the last step, what you have to do is you have to extend this. You can extend any of the forces, either F32 you can extend, if not F12 you can extend. It's up to you. Take protractor. You can take any one reference point. This reference point can be anywhere along line F12. You can keep it wherever you wish. Keep your protractor, draw a 90-degree line. We'll repeat this step. You can take one reference point anywhere along line F12. Set your protractor here. Draw a 90-degree line. This line has to be 90 degree. And measure the dimension of this line. This is, say, suppose it is X. Then the final answer, torque is given by F12 or F32 or F32 into H or X into X. So like this, you can calculate what is the torque value. I think torque value in the first half, in the first part, you will get a torque value 64,400 Newton mm. You can note down answer. You can verify it later. 64,400 Newton mm. So this is not the final solution. We have completed only first part of the solution. Second part is remaining. So now we'll explain how to complete the second part. I think second part you yourself can complete. So in second part, what I'm doing is we'll neglect force acting on piston. We'll neglect force acting here. We'll consider only this 800 Newton. We'll consider only 800 Newton now in second half. It is acting at an angle of 60 degree. 60 degree. This is point A, point B, and point C. You can write here, this is part B or part 2. So what is the first step? You have to draw individual links. You have to draw of individual links. So we'll draw link number 4 here. This is link number 4. We'll draw link number 3 here. This is link number 3 and also link number 2. Procedure is similar to part A. Link number 4, link number 3, and link number 2. Which are the forces on? Which are the forces acting on link number 3? Link number 4 now. Which are the forces acting on link number 4 now? How can you identify that? Link number 4 is connected to link number 3. Link number 4 is connected to link number 1. Therefore, only two forces will be acting now. Two forces are F. 3 is applying force on 1. Sorry, 3 is applying force on 4. 1 is applying force on 4. F34 and F14. So these are the two forces acting on link number 4. And always I told you, one force will be acting in exactly vertical direction. F14 will be always acting in vertical direction. F14. Now for the balancing or for the equilibrium, second force must be equal in magnitude because there are only two forces. Therefore, second force must be equal in magnitude and opposite in direction. So this one has to be F34. Note down the difference between this problem and previous problem, first part and second part. In first part, you had 3 forces, but in second part, there are only 2 forces acting on link number 4. So when only 2 forces are acting, these 2 forces must be equal in magnitude and opposite in direction. Direction of F14, it's always vertical. Always this fixed portion will be exerting a vertical reaction on sliding part. So this will be the direction of F14, and for balancing, F34 will be acting on exactly opposite direction. So moving on to next link, link 3. How many forces? Link number 3 is connected to 4, link number 3 is connected to 2. Therefore, F43, 4 is applying force on 3. F23, 2 is applying force on 3. Apart from this, one more force of magnitude 800 Newton. These are the 3 forces acting on link number 3. Out of these 3 forces, here itself I will write magnitude and direction. Magnitude and direction. What about magnitude of 800 Newton? Magnitude is known. What about direction? Direction is also known. So this is point B. This is point C. At a distance of BD. BD is 200 mm. So from B at a distance of 200 mm, locate point D. And at an angle of 60 degree, at an angle of 60 degree, mark 800 Newton. And I told you I'm drawing free body diagram now, not force polygon. And for this free body diagram, dimension is not important, only direction is important. Angle is important, magnitude or length is not important. For force polygon, both magnitude and direction is important. For free body, only angle is important. So you can simply draw one line inclined at 60 degree. So this is over, 800 Newton is complete. And out of F43 and F23, whose magnitude or whose direction is known? Magnitude is unknown for both F43 and F23. But whose direction is known? Do you know the direction of F23? For that, you have to refer previous diagram. There is no F32 in the previous diagram, so its direction is unknown. But F43, if you consider, in the previous diagram, I'm having F34. So the direction of F34 and F43 will be opposite to each other. So the direction of F34 is exactly vertical. So even this one will be acting in exactly vertical direction. So at C point, it is F34. Therefore, I'm marking at point C because C is connected to link number 4. Point C is connected to link number 4. So at C, we'll draw one exactly vertical line. This line is vertical because F34 is vertical. And this line represents F43. F34 and F43 must be opposite in direction. So these two must be exactly vertical. So this line represents 800 Newton. This line represents F43. Now how to get the last F23 direction? In order to get direction of F23, that procedure is simple. You have to connect this point B with this point E. Say suppose this is point E. Connect point B with point E. That will be the direction of F23. That will be the direction of F23. Remember, from this diagram, I cannot get magnitude. I'm drawing free body diagram. It's not force polygon. For getting magnitude, you have to plot force polygon. This is free body diagram. From free body diagram, you can get only direction, only angle you can get. So I got the direction, or I got the angle of F23 now. Moving on to last link. Link number 2, which are the forces? Forces are F. Link 2 is connected to 3, so F32 and F12. And there is a torque also. This torque is common in both first and second part. F32, F12 and a torque. Out of F32 and F12, whose magnitude is known? For that, refer previous diagram. Do you have F21 in previous diagram? I don't have F21 in previous diagram, but I'm having F23 here. I'm having F23. So F23 and F32 will be opposite to each other. So parallel to F23, we'll draw a line. These two will be parallel to each other. This will be F32. This is F32. Since there are only two forces, next force will be equal in magnitude but opposite in direction. So this will be the direction of F12. So this will be the direction of F12. Again, I'm telling for all the three diagram, length is not important, only direction is important. So after drawing this, next we'll go for force polygon. For force polygon, length is important. Okay, then we'll plot the force polygon now. While constructing force polygon, which link to be considered first, whether link number 4, 2 or 3? How can you identify that? I need minimum 3 forces. Link number 4, if you consider I'm having only 2 forces, I cannot construct a force polygon for link number 4. Link number 2, if you consider again I'm having only 2 forces, so I cannot construct a force polygon for link number 2. Link number 3, if you consider I'm having 3 forces, so you can construct a force polygon for link number 3. So first construct a force polygon for link number 3, and while constructing force polygon, both magnitude and direction is important. So first we'll start with 800 Newton. Its magnitude is known, direction is known. So we'll draw a line. 800 Newton is equal to around 4 centimeter. You can take, it's up to you. 200 Newton is equal to 1 centimeter. So 800 Newton will be 4 centimeter. Its magnitude and direction both are known. So that will be the first line. And second line will go for F23 or F43. It's up to you. You can start with any line. Next we'll plot F43. What is the direction of F43? It is exactly vertical. Its length is unknown. This is F43. We'll simply draw one line. This is F43. This is 800 Newton. And the last line F23. From this point, draw a line parallel to F23. This one must be parallel to F23. This line represents F23. So draw a parallel line to F23 in free body diagram. So from this force polygon, you will get magnitude of F43 and also magnitude of F23. Magnitude of F43, you will get 280 Newton. F43 will be 280 Newton. Magnitude of F23 will be 640 Newton, I think. This is 640 Newton. Now the last step. I cannot plot a force polygon for link number 4 because there are only 2 forces. So we'll go for link number 2, last step. Hope you can construct force polygon for link number 2. Similar to previous problem, link number 2. Draw 2 lines. One here one more here. This one must be parallel to F32 and F12 in the previous diagram. So this represents F32, this represents F12. What will be the magnitude of F32? F32 and F23 will be same. Therefore, F32 is equal to 640 Newton. 640 Newton. In order to get magnitude of any force, you have to refer previous diagram. There check, do you have F23 or F21, anything like that? So I'm having F23 in the previous diagram, so the magnitude of F32 will be equal 640 Newton. Now how to calculate torque? Extend it. Extend it. Mark any one point. Keep your protractor. Draw a 90-degree line. This one has to be 90 degree. And measure this dimension, vertical height. If it is x, then torque is equal to T2 F12 or F32 into x. So final answer I will tell you. You will get F32 is 640 Newton into x. You will get 96,000 Newton mm. 96,000 Newton mm. Now the final answer. Total torque is equal to T1 obtained in first part plus torque obtained in second part. Torque obtained in first part was 64,400. 64,400. And the torque obtained in second part was, it is 96,000. 96,000. So by adding these two, you will get the final answer, final torque. This is the final answer. So we'll quickly summarize it, just 2 more minutes. One second. Yeah, this is the problem given. First, divide it into two parts. In first part, consider any one force. So I have neglected this force. I have considered only 2000 Newton. Then the solution will be similar to problem number 1. Calculate what is the torque. In second part, I have neglected this 2000 Newton. I have considered only 800 Newton. Draw free body diagram of individual links. Link number 4, link number 2, and link number 3. And link number 3, if you consider, there are 3 forces, F43, F23, and 800. For drawing this free body diagram, magnitude is not important, only direction is sufficient. Both magnitude and direction is known for 800 Newtons. So you plot a line parallel to 800 or 60 degree, line inclined at 60 degree. Then direction of F43 is known because it is exactly vertical. F34 and F43 will be opposite to each other. So draw one perpendicular line or vertical line. Connect point B with this intersection point E. You will get direction of F23. It's not magnitude of F23. You will get direction of F23. Then plot free body diagram for link number 2. There are only 2 forces, F32 and F12. Then finally plot force polygon. While constructing force polygon, both magnitude and direction is important. So you have to start constructing force polygon from a link in which there are 3 forces. So only in link number 3 there are 3 forces. Construct force polygon, you will get different forces acting on that particular link. Then go to second link. This procedure is similar to step number 1. Calculate torque. Add torque obtained in first part and second part, you will get final answer.